In this video, I'm going to talk you through the solutions to the back of the first page, or in other words, page 2 of the Unit 7A through 7C review packet. Again, the first question I'm going to ask myself when I'm graphing an equation is, what form is that equation in? And when I look at this, I see an x squared and an x, which tells me that this is going to be in standard form. So I have to think through, how do I graph an equation if it's in standard form? Well, I know my very first step is to find the axis of symmetry. So step 1, find your axis of symmetry. And there's a formula, x equals negative b, or the opposite of b divided by 2a. So I'm going to put a 1 around that because that's the first thing I did. So a in this equation, because I don't see a coefficient of x squared, that's just 1. B is a positive 6, and c is 5. Notice I did not write an x squared or an x, it's just the number. So my axis of symmetry is x equals the opposite of 6 divided by 2 times 1, or negative 6 divided by 3, or negative 2. So my axis of symmetry is x equals negative 2. And I got to make sure I remember to put that x equals, otherwise it's just a number, it's not an equation of a line. Once I do that, I know that my vertex is on the axis of symmetry, so I'll try and find my vertex using the axis of symmetry. So next up is vertex. Just like when I was in intercept form, I took that axis of symmetry value and I substituted into my equation. Now remember, when you substitute in, you have to have parentheses. That's going to be key when we are simplifying. So if I want to use my calculator, I can do that. Or if I just want to remember order of operations. Oh, you know what? I made a mistake. Let's go back. I apologize. 2 times 1, that's not 3, that's 2. And negative 6 divided by 2 is 8, negative 3. Oh my goodness, we almost... There we go. So negative 3. So now I'm substituting negative 3 for x. There we go. All right. So negative 3 squared is a positive 9. Now I do my multiplication. 9 minus 18. And when I add all those terms up, I get a negative 4. So my vertex will have an x coordinate that is the same as the axis of symmetry. And there's my y coordinate, negative 4. So I can plot that point. We had our axis of symmetry at x equals negative 3. Our vertex was on that axis of symmetry, right there. Now I do need other points in order to graph this equation, to get this parabola the correct shape. So the extra points I'm going to get by substituting in x values. I have x is negative 3, so if I go to the left or to the right one, that could give me another x value. So let's go to the right. I get x equals negative 2 there. So let's substitute x equals negative 2. When I substitute in x equals negative 2, excuse me, I get y equals negative 2 squared plus 6 times negative 2 plus 5. Or 4 minus 12 plus 5, would that be negative 8 plus 5, which is negative 3. Or again, like I said, you could substitute that into your calculator, this whole thing, and just show me that is equal to negative 3. So we have the point negative 2 comma negative 3 that we can plot. Negative 2, negative 3. And the nice thing about this is because a parabola is symmetrical, I can reflect that over the axis of symmetry and I have another point. Now this is not enough to get the full picture, so I can substitute another x value in. One x value that I always love to try is x equals 0, because I know when x equals 0, that's finding my y-intercept. So let's do that as our fourth step. Find that y-intercept, and let's see if that's going to fit on our graph. And if it does, that'll be a nice extra point. Well, 0 squared is 0, 6 times 0 is 0, so we're just left with 5. So our y-intercept is 0, comma 5. And I can plot that, and again reflect it, and now I have a really good idea of what the shape of this graph is. If you wanted to plot another point you could substitute in, we would end up finding that these guys right here would be my other 2 points, and now I can create that nice smooth parabola graph. Alright, the other things that it's asking us to find: domain and range, equation, vertex form, and transformations. Well, domain, because the graph goes forever to the left and right, there is no restriction on the domain. It is all real numbers. When I look at this graph opening up, I see that there is no maximum, but there is a minimum here. There's a lowest point, and that lowest point has a y value of negative 4. So all of the other y values have to be greater than or equal to negative 4. To write the equation in vertex form, I just need the vertex and the a value. If I look here, the a value is 1. I got my vertex, so I'll just write it as x plus 3 squared minus 4. There's no need to write the 1 because it is implied. And then finally the transformations. Again, I look at my vertex, I translate to the left 3 and down 4. So translate left 3, down 4. I always got to see, is there a reflection? Well, because this is opening up, there is no reflection in the x-axis, or because my a value is positive, I know there's no reflection. I do have to look for a vertical stretch or shrink. Is it narrower or wider than the parent function? And because a is 1, it is actually the same width as the parent function, so my only transformations are translate left 3 and down 4. Moving on to the next graph here. When I see this, I only see one set of parentheses, so sometimes I'm inclined to think that this would be vertex form. However, I see two x's being multiplied together and nothing's being squared. So that tells me this is actually intercept form. And I'm reminded that when something's in intercept form, the very first thing I'm going to do is find those x-intercepts. I find the x-intercepts by letting y equal 0 and then solving for x. When it's in intercept form, to solve for x, I need to use the zero product property. I can set each factor equal to 0. Negative 3x equal to 0, and x plus 2 equal to 0. To solve for x over here, I just divide by negative 3, and to solve for x over here, I subtract 2. So my two x-intercepts are 0, 0, and negative 2, 0. And I can plot those points. 0, 0, negative 2, 0. Now, my vertex is very important, and I know I'm going to get my vertex by first finding my axis of symmetry. And the axis of symmetry happens to go right through the middle of those x-intercepts. So this is step 2. Now I could look and to see that that's x equals negative 1, but in a later problem, maybe it'll be easier to substitute in to find the average. So if my x-intercepts are 0, negative 2, 0 plus negative 2 over 2, that will give me my equation for the axis of symmetry if I just find the average there. And I still get x equals negative 1. Again, we said to find the vertex, we first found the axis of symmetry, but since we're finding the axis of symmetry in order to find the vertex, that will be our next step. So step 3, substitute in that x value of the axis of symmetry into the equation to find the y value of the vertex. So now I just simplify using order of operations. I simplify parentheses first, but I'm looking inside the parentheses. Inside those parentheses, there's nothing to simplify. But inside these parentheses, there is. So we still carry down this negative 3 times negative 1. Here, negative 1 plus 2 is a positive 1. Now we're just multiplying three numbers from left to right. I'm going to multiply in order from left to right. Negative 3 times negative 1 is a positive 3, times 1 is 3. So my vertex has coordinates negative 1, comma 3. Negative 1, comma 1, 2, 3. If I want to substitute in extra x values, I can. So we'll maybe step 4, some extra points here. So let's substitute in when x equals 1. So f of 1 would just be negative 3 times 1 plus 2. Again, if I just simplify this using order of operations, I do get the point 1 comma negative 9. And if I reflected that, that would be the same distance on the other side. And now I have a very nice shape for my graph. Okay? The y-intercept, well, I don't have to do any work for it. I already saw it's 0. 0, comma 0. I already have that on my graph. The domain and range, domain again will be all real numbers because there is no restriction going left and right. However, there is a maximum value here. The maximum value would be 3. So all the y values are 3 or below. So y is less than or equal to 3. Alright, now this one did not ask us to identify the transformations from the parent function, but for this one, if it did, we would be translating to the left 1 and up 3. It would be a reflection because we're opening down. And because this is narrower than the parent function, this would be a vertical stretch. Or because this a value has a 3, it would be a vertical stretch. Alright, now the equation in vertex form, all we need is the vertex, so we got that. And the a value is negative 3. We'll do x plus 1 opposite the sign, and then keep the other sign. Standard form, I need to convert either from vertex form or from intercept form to standard form. And I'll tell you, this one is definitely easier just to convert from intercept form. I distribute that. I get negative 3x squared minus 6x. And there's my equation in standard form. Finally, for this page, the very last graph, I look at this, I see an x squared and an x. That tells me that this is standard form. And again, if the equation is in standard form, the very first step is to find the equation of the axis of symmetry. It doesn't ask us for it down here, but I know I need to find it. So the very first step, axis of symmetry. Again, we do that with x equals negative b, or the opposite of b over 2a. So in this case, a is equal to 4, b is negative 4, and c is negative 6. So the opposite of negative 4 divided by 2 times 4, or a positive 4 divided by 8, or 1/2. All right, so now I use that to find the vertex. So let's first graph this. We know the vertex is somewhere along this dashed line, somewhere along this axis of symmetry. So step 2, g of 1/2 would equal 4 times 1/2 squared minus 4 times 1/2 minus 6. Now if you wanted to, you could enter that all in your calculator. Or if we're practicing our mental math skills, we can multiply this, do it out by hand. First do our exponents. 1/2 squared would be 1/4. Now if I multiply, 4 times 1/4 is 1. Negative 4 times 1/2 is a negative 2. And then if I just 1 minus 2 is negative 1. Negative 1 minus 6 is a negative 7. So my vertex is 1/2 comma negative 7. And I'll plot that point right there. Now I do need some extra points in order to get a better shape for my graph. So to do that, I will substitute in other x values. So my third step is getting some extra points. First one I might substitute in is x equals 0. Finding the y-intercept, we got to do it down here anyway. So g of 0 equals 4 times 0 squared minus 4 times 0 minus 6. Well, that's just 0 minus 6, or negative 6. So the y-intercept is 0 comma negative 6, or this guy right here. And I can reflect it, and you're good to go there. Okay, now that's still really close to each other, so let's go ahead and substitute another x value. What about x equals, we're already 0, 1/2, 1. Let's try 2. X equals 2. So we'll find g of 2. So 4 times 2 squared minus 4 times 2 minus 6. Order of operations tells me I do exponents first. Now I multiply. So we get 2 comma 2. 2 comma 2. I can reflect that and get this point right here. And now that gives me a pretty good idea of what the shape of this graph looks like. There you go. Alright, jumping down to the rest of the things it's asking us. Domain, again, all real numbers. It's not restricted going to the left or to the right. But this graph has a minimum value for our y value. So the minimum value would be negative 7. Anything else is above it. So y greater than or equal to negative 7. For vertex form, I need that a value. I get that from the original equation. A is 4. X minus 1/2 squared minus 7. And there you go. That is our second page of the review packet.